Hello students! I'm here again, Samsudin and Abdullah, one of the senior high school mathematics teachers of Esperanza National High School. And this is a second video lesson on the first week of the first semester of the new normal school year 2020-2021. And we are going to discuss a very important topic, and that is all about odd and even functions. What is the difference between odd function and even function? Odd functions and even functions are functions that satisfy specific symmetry relations. In algebra, there are three specific symmetry relations. The first symmetry relation is with respect to the origin of the Cartesian plane. The second symmetry relation is with respect to the y-axis of the Cartesian plane. And the third symmetry relation is talking about a symmetry relation with respect to the x-axis. And what particular symmetry relation if we are going to have the so-called odd functions? And what is specific symmetry relation if we have the even functions? If the function is odd, then its graph is symmetric about the origin. For instance, f of x is equal to x raised to 3 is an odd function because if we are going to get the additive inverse of x, and that is equal to negative x, the result is equal to negative f of x, and this negative f of x is the additive inverse of the function f of x. It means that if we are going to add f of x and negative f of x, the result is equal to 0. That is the meaning of additive inverse. Then, if we are going to add also x and its additive inverse, which is negative x, the result is equal to 0. Now, if two numbers being added will be resulting to 0, these two numbers are said to be additive inverses of each other. We are going to determine if f of x is equal to x raised to 5, whether it is an odd function or not. And this is an odd function because if we are going to consider one value of x and that is equal to 2, and we are going to substitute to this particular function, f of x is equal to x raised to 5, and the result is equal to 32. Why 32? 2 times 2 is equal to 4, times 2 is equal to 8, times 2 is equal to 16. 16 times 2 is equal to 32. And we are going to take the additive inverse of 2, and that is equal to negative 2. 2 and negative 2 are additive inverses. Why? Because if you are going to add 2 and negative 2, the result is equal to 0. Then we are going to get the value of y if x is equal to negative 2. So, we have negative 2 times negative 2 is equal to positive 4. Positive 4 times negative 2 is equal to negative 8. Negative 8 times negative 2 is equal to positive 16. Then, positive 16 times negative 2 is equal to negative 32. And 32 and negative 32 are additive inverses because 32 plus negative 32 is equal to 0. And if that will be the case, we can conclude automatically that a certain function is an odd function. Now, how are we going to determine that this particular function is to be tested with the idea of odd function? If the highest exponent is odd. That is why 5 is odd, and we tested if this particular function is odd function because of the exponent 5. And so with f of x is equal to x raised to 3, the highest exponent or the degree is equal to 3. That is why we are going to verify if this particular function is an odd function or not. Now, how about if we are talking about even function? What particular symmetry relation is being reflected if we are talking about even functions? Because just a while ago, we can say that a certain function is odd if the symmetry relation with respect to the origin is being observed. How about if we are talking about even functions. There are two remaining symmetry relations that we have in algebra. We have a symmetry relation with respect to the y-axis, and we have the symmetry relation with respect to the x-axis. Which of these two symmetry relations is being observed if we are talking about even functions? And this is the answer. If the function is even, then its graph is symmetric about the y-axis, and that is the vertical axis of the Cartesian plane. For instance, f of x is equal to x squared is even function, because if we are going to take the additive inverse of x, and that is negative x, the result is equal to the same with that of the particular function that we have just a while ago. Meaning, there is no change with that particular function. And why do we need to test if this particular function is even? If the degree of the function is 2, then we are going to determine whether this particular function is even or not. Another example is f of x is equal to negative x raised to 4. And this is also even function, because if we are going to consider one value of x, and that is equal to 3, and we are going to substitute 3 to the function f of x is equal to negative x raised to 4, and what will be the result? The result is equal to negative 81. Why negative 81? Because we have negative quantity 3 quantity raised to 4 is equal to, we are going to simplify first the number inside the parenthesis before we are going to multiply it to negative 1. So we have 3 times 3 is equal to 9. Times 3 is equal to 27. Times 3 is equal to 81. Then 81 times negative 1 is equal to negative 81. Then we are going to take the additive inverse of 3, and that is equal to negative 3. And we are going to solve if the answer is still negative 81. And if that is the case, our function is even, and that is not odd function. The result is still negative 81. Why? Because if we are going to substitute negative 3 to f of x is equal to negative x raised to 4, the result is negative 81. So we have negative quantity, negative 3 quantity raised to 4. So we have to simplify first the expression inside the parenthesis. So we have negative times negative is positive. 3 times 3 is equal to 9. Then 9 times negative 3 is equal to negative 27. Then negative 27 times negative 3 is equal to positive 81. Then 81 times negative 1 is equal to negative 81. And negative 81 is equal to negative 81. It means that if we are going to substitute the two numbers, and these two numbers are additive inverses of each other, the result is the same. We can say that this function is even function. Now, is f of x is equal to negative x raised to 3 plus 1 an odd function? Why do we need to test if this particular function f of x is equal to negative x raised to 3 plus 1 an odd function? Because the degree is 3. And it is very impractical to test this particular function whether it is an even function or not, because the degree is 3. That is why we are going to test whether this function is an odd, because of the highest exponent of the function. And the answer is definitely no, because if we are going to consider one value of x, and that is 1, and we are going to substitute to f of x is equal to negative x raised to 3 plus 1, the result is equal to 0. Why 0? Because negative quantity 1 quantity raised to 3 is equal to 1 times 1 times 1 is equal to 1. Times negative 1 is equal to negative 1. Then negative 1 plus 1 is equal to 0. Then we are going to take the additive inverse of 1, and that is negative 1. And we will substitute to the function f of x is equal to negative x cubed plus 1. So we have negative quantity, negative 1 quantity raised to 3. Negative times 1 times negative 1 is positive 1. Positive 1 times negative 1 is equal to negative 1. Then negative 1 times negative 1 is equal to positive 1. Then 1 plus 1 is equal to 2. And 2 and 0 are not additive inverses. Why? Because 2 plus 0 is not equal to 0. If two numbers being added will not be resulting to 0, these two numbers are not additive inverses. If two numbers, if added, will be resulting to 0, these two numbers are additive inverses of each other. Now, we are going to check if f of x is equal to quantity x plus 1 quantity squared an even function. So we will not test this particular function whether it is odd or not because the degree is 2. That is very obvious that this is not an odd function. But we are going to test if this particular function is even because of the degree of the function, which is 2. And this is definitely no, because if we are going to consider one value of x. Take note, any value of x here could be. It could be 0, it could be 1, it could be negative numbers, but we will just only consider one value, and that is 2. Then we are going to substitute 2 to the function f of x is equal to quantity x plus 1 quantity squared, and what will be the result? And that is equal to 9, because 2 plus 1 is equal to 3. 3 raised to 2 is equal to 9. Then we are going to take the additive inverse of 2, and that is equal to negative 2. And we are going to solve what will be the result. And the result is equal to 1. How did you get 1? We have negative 2 plus 1 is equal to negative 1. Negative 1 raised to 2 is equal to positive 1. Then, 9 is not equal to 1. It means that if we are going to substitute negative 2 to f of x is equal to quantity x plus 1 quantity squared, the result is equal to 1, and 1 is not equal to 9. That is why this particular function f of x is equal to quantity x plus 1 quantity squared is not an even function. Now, f of x is equal to negative x raised to 3 plus 1, and f of x is equal to quantity x plus 1 quantity squared are neither odd function nor even functions. This means that this is neither an odd nor even function. And so with f of x is equal to quantity x plus 1 quantity squared is neither an odd nor even function. Now, this time, we are going to deeply understand the meaning of odd and even functions using their corresponding graphs. Consider this first figure in which this curve is symmetric with respect to the origin, and this point with coordinates x and f of x is symmetric with this point with coordinates negative x and f of negative x. This point below the x-axis has the equal distance with this particular point above the x-axis with coordinates x and f of x. That is why we can say that this particular graph is symmetric with respect to the origin, and this curve is symmetric with this particular curve. And if that is the case, that graph is an odd function. Now, consider the second figure here. This is a parabola opening upward with vertex along the y-axis, and this is even function. And now, let us proceed with exercises. We will start from a very simple exercise. Direction. Tell whether its equation is odd, even, or neither from its equation. Write odd function, even function, or neither. Number 1. Y is equal to negative x cubed. Take note, this is obviously odd function because the degree of the function is 3 and we have only a single term. And the point of symmetry is in the origin, and this is the graph of a cubic function. And this is an odd function. Number 2. Y is equal to quantity x plus 1 quantity squared is a parabola opening upward and the vertex is along the x-axis. Now, if the vertex is along the x-axis, the graph is never be symmetric with the y-axis. That is why this is not an odd function nor even function. Therefore, our answer is neither. Number 3. Y is equal to 1 minus x raised to 3, and this is a cubic function. Take note, we have a constant 1 here, and a constant is understood to be having a variable x with exponent 0. And 0 is even, and this is an odd. Therefore, this is not an odd function nor even function. Our answer is neither. Take note, the graph of this function is a curve with point of symmetry, but the point of symmetry is not the origin. That is why this is not an odd function nor an even function. That is why our answer is neither. And the technique is that you are going to consider the constant term here 1, and this constant term is having a variable x with exponent 0. Now, if there is a combination of the exponents, we have the odd and even in that particular one function, that is automatically a function which is never classified as odd nor even function. Let us proceed with number 4. Y is equal to x raised to 5 plus 2. And this is neither an odd nor even function. Why? Because of the constant term. Because the constant term here has the variable x with exponent 0. Because x raised to 0 is equal to 1. And 1 times 2 is equal to 2. But if we are going to remove the constant term here, we have y is equal to x raised to 5, and that is already an odd function. Number 5, y is equal to 3 minus x squared. This is a parabola opening downward, and the vertex is along the y-axis. If our vertex is along the y-axis and our parabola is opening upward and opening downward, our parabola is an example of even function because that parabola is symmetric with the y-axis since the vertex is along the y-axis. So let us proceed with number 6. Y is equal to 3x raised to 5, and this is just only a single term, and the degree of the function is 5, and automatically this is an odd function. Number 7, y is equal to 3x, and this is a linear function and the degree is 1, and since we have only one term here, this is an odd function because the graph of this particular function is a line passing through the origin and the slope is positive. Therefore, we can consider that half of the line is symmetric with that half of the line below the x-axis. And number 8. Now, this is a cubic function, therefore the graph is a curve with point of symmetry. But the point of symmetry is not the origin, and this is never be an odd function. Because if we are going to expand this particular equation, this will be resulting to function with 4 terms. We have the cubic term, we have the quadratic term, we have the linear term, and we have the constant term. Therefore, the exponents of x are combination of odd and even. That is why that is never be classified as odd function nor even function. Therefore, our answer here is neither. Number 9, y is equal to negative quantity x plus 3 quantity squared. And this is a parabola opening downward and the vertex is along the x-axis. Since that the vertex is along the x-axis, the parabola is never be symmetric with respect to the y-axis. Therefore, this is never be classified as even function, especially never be classified as odd function because the degree of the polynomial function or the quadratic function is 2. Therefore, our answer here is neither. Number 10, y is equal to 2x squared plus 3 and our degree is 2. And we have the constant term here. This constant term, 3, has the variable with exponent 0. And the exponents are 2 and 0. Therefore, this is an even function. Because this is a parabola opening upward in which our vertex is along the y-axis. Specifically, the vertex is 0 and 3. Therefore, our parabola, if we are going to graph this parabola, the parabola is opening upward and the axis of symmetry is the y-axis and that is symmetric with the y-axis. Now, let us proceed with the second type of exercise in which we are going to tell whether its graph is odd, even, or neither. Right odd function, even function, or neither. Now, this is very simple because as what we have discussed in the previous slides, it's very simple to identify whether a certain graph is even or odd or neither because if our graph is symmetric with origin, our graph is odd function. If our graph is symmetric with the y-axis, our graph is even function. If our graph is not symmetric with the origin and not symmetric with the y-axis, and that is never be an odd function nor even function. Number 1, this is a parabola opening upward and this is symmetric with respect to the y-axis. Therefore, this is an even function. Number 2, this is a cubic function in which our point of symmetry is the origin and this curve is symmetric with this curve. Therefore, this is an odd function. Number 3, this is a half of ellipse. Now, this particular graph is symmetric with respect to the y-axis. Therefore, this is an example of even function. And now, let us proceed with number 4. The graph is a parabola opening downward and its vertex is along the y-axis. And as you can see on the graph, the left side of the curve is symmetric with the right side of the curve and that is using the axis of symmetry which is the y-axis. That is why this is an example of even function. Let us proceed with number 5. Our graph is symmetric with respect to y-axis. Therefore, this is an example of even function. Number 6. This is a curve with similar characteristics with this particular curve. But, of course, they have the difference. And the major difference is the symmetry. Because this curve is symmetric with origin. And this is an odd function. Number 7, and this is a line in which it passes through the origin and that divides the quadrants into two congruent parts, and this ray is symmetric with this ray with respect to the origin, and this is an example of an odd function. Number 8, the graph is a curve which is symmetric with each other, but the point of symmetry is not the origin. That is why this is not an example of odd function nor even function. And our answer here is neither. Number 9, this is a graph of a cubic function in which the point of symmetry is along the y-axis. But this point of symmetry is not the origin. That is why the graph is not symmetric with respect to the origin. Therefore, this is neither classified as odd function nor even function. And the answer is neither. Number 10. This graph is a graph of a quartic function in which we have the three turning points. We have the first turning point and the second turning point, and this is the third turning point. The graph of this quartic function is not symmetric with respect to the y-axis because this is a smaller curve compared with this another curve which is larger than this particular curve. That is why this is neither an odd function nor even function. Number 11, and this is a graph of a cubic function in which we have the two turning points, and this graph is passing through the origin and it is symmetric with respect to the origin because this curve is symmetric with this curve. That is why this is an example of odd function. And number 12, and this is a graph of a quartic function in which we have the three turning points. As you can see on the graph, the first and the third turning points are symmetric with each other about the y-axis. And this curve is symmetric with this particular curve because the shape of this curve is exactly the same with the shape of this particular curve. And we have the two symmetric points here in which if we are going to look for the distance from this point up to this point and considering the point from the origin going to this point, the distance between this line segment is equal to the distance of this line segment. That is why this is an example of even function. Direction. Show algebraically whether each function is odd, even, or neither. What you are going to do is to get the additive inverse of x, and the additive inverse of x is negative x, and you are going to substitute this negative x to the original function, and if the result will be giving you the negative of that particular function, we can say that a function is odd. But if the result is the same with the original function, after substituting negative x to the function, we can say that that function is even function. I am going to give you the technique. How are you going to easily identify whether the function is odd, even, or neither? But there is also a solution that you need to show because this will train you how you are going to solve problems using the solution and using the mental solution. Number 1, f of x is equal to negative 3x raised to 3 plus 2x. How are you going to do in order to test whether this particular function is odd or even? you are going to consider the additive inverse of x. And the additive inverse of x is equal to negative x. And you are going to substitute this negative x to each term of the particular function. Then, if the result will be the negative of that particular function, or the result would be the additive inverse of the particular function, we can say that that function is odd. Then, after substituting negative x to each term of the particular function and the result will not change, we can say that function is even. But we can automatically identify that number 1 is odd because of the exponents. Take note, there are two exponents here, exponents of x. We have the 3 and we have 1. And 3 and 1 are all odd. Therefore, we can automatically conclude, even without algebraic solution, that this particular function is odd. But, for the sake of the direction in which you're going to show algebraically the solution, whether it is an odd, even, or neither, before you're going to have your conclusion, you have to show first your solutions. We are going to show the solution. What you need to do here is to copy first our function. Then after that, you are going to get the additive inverse of x, and that is negative x, and substitute that to the each term of the function. That is why from x that becomes negative x. We have also here negative x. Then after that, you are going to simplify. What you need to do is to split negative x raised to 3 into this particular situation so that you can simplify negative 1 raised to 3, and that is negative 1. Because negative 1 times negative 1 is positive 1 times negative 1 is negative 1. Then negative 1 times negative 3 is positive 3 already. And negative 1 times x is negative x times 2 is negative 2x. Now, we are going to observe if this function is the additive inverse of this particular function. What you need to do is you are going to add mentally. If 3x cubed minus 2x plus negative 3x cubed plus 2x will be giving you a result of 0, we can say that these two functions are additive inverses of each other. If these two functions are additive inverses of each other, we can say that that function is odd. How can you determine if these two functions are additive inverses of each other? So you're going to add two functions. If the result is equal to 0, that functions are additive inverses of each other. Another technique is get the negative of this polynomial, and this is it. Get the negative of this. If you are going to get the negative of this particular function and the result is this, you can also conclude that these two polynomials are additive inverses of each other. But what we need to do here is to get the negative of this particular resulting function after substituting with the additive inverse of x, and if after getting the negative of this resulting function will be the same with the original function, we can say that this function is odd. So, get the negative of this function. So, we have negative 1 times 3x cubed is equal to negative 3x cubed. Observe. Then, negative times negative is equal to positive. Then, 1 times 2x is equal to 2x. Therefore, f of negative x is equal to negative f of x. Therefore, we have to observe. That is why we can say that this is an odd function. Now, we will proceed with number 2. We are going to test whether this is an odd or even. Take note, the first thing that we're going to do is to observe the exponents. The exponents are 6, 4, and 2. And we have x raised to 0. All exponents are even. Even without showing the algebraic solution of this particular function, we can say that this function is even. But for the sake of the direction, we are going to show our solution. f of negative x is equal to this one. Instead of writing x, you're going to substitute x with negative x. Don't forget the exponents, same exponents. Then after that, you are going to simplify. If the result will be the same with this particular function, we can say that this function is even. So this is negative x raised to 6 is equal to positive x raised to 6. Because negative 1 raised to 6 is equal to positive 1. 1 times x raised to 6 is equal to x raised to 6 times 3. Therefore, we have the result 3x raised to 6 minus 8x raised to 4 plus 5x raised to 2 plus 6. The result is the same. We can say that f of negative x is equal to f of x. It means that there is no change with respect with the terms of the function. So observe, this is an even function. Now we will proceed with number 3. f of x is equal to 2x raised to 4 minus 7x raised to 3 plus 3x raised to 2 plus 1. Observe all the exponents. We have 4, we have 3, you have 2, and you have x raised to 0. We have the 0 exponent there. Now, all of the exponents are even except 3. We can say that this is neither an odd nor even because there is an odd exponent in which we have the even exponents 4, 2, and we have 0. Therefore, this is not an even nor odd. But we are going to show the solution. What are we going to do is to substitute negative x with each of the term of this particular quartic polynomial function. So this is it. So negative x raised to 4 minus 7 quantity negative x raised to 3 plus 3 quantity negative x raised to 2 plus 1. Take note. If a negative number is raised to an even number, the result is positive. Therefore, this is positive x raised to 4 times 2 is this same. But our problem is here. Because from negative, it became positive. It means this function is not the same with this. So we can conclude that this is not even. Because we have here the difference. The second term. Why? Because negative x raised to 3 is negative x cubed. And that is negative 1, of course. If you're going to split it from the coefficient, negative 1 times negative 7 is equal to positive 7 already. So the result would be 7x raised to 3 plus negative x times negative x is equal to positive x squared times 3 is 3x squared. Same. And it is also same, but the problem is here. And we can say that f of negative x is not equal to f of x because of this particular term, and that is different from that. Take a look in these two functions. They are different from each other. We can say that this is neither an odd or even. Now we will proceed with number 4. And this is a rational function. What we are going to do here is to solve. I will not give you the technique first. We are going to solve. You are going to substitute negative x with this rational expression. So this is it. This is negative x. And you have 2 quantity negative x raised to 5 plus quantity negative x raised to 3. Then, we are going to simplify. This is negative x, and this is negative because negative x raised to 5 is equal to negative x raised to 5 times 2 is negative 2x raised to 5 minus, okay, this is negative x raised to 3 is negative x raised to 3 times 1 is negative x to 3. And we are going to simplify because all of the terms are negative. So we are going to simplify this one. So this becomes, okay, negative quantity x. And this becomes negative quantity 2x raised to 5 plus x raised to 3 quantity. And we are going to cancel this out. Did you understand, students? We are going to cancel this out. And this is equal to f of negative x is equal to x over 2x raised to 5 plus x raised to 3. And you are going to observe, we have obtained that f of negative x is equal to f of x. It means that this is an even function because after substituting negative x with each of the term of this rational expression, the result is the same with this particular function. And this is even function and it can be validated by the graph. The graph is this one. The graph is symmetric with respect to the y-axis. The technique that we have shown just a while ago is just only applicable for polynomial functions. For rational functions, it is not applicable. Why? Because all of the exponents here are odd. But this is resulting to even function. So do not apply the technique in rational function. Now we will proceed with number 5. F of x is equal to 1 over x raised to 7 plus 4, and this is a rational function. So we are going to verify by substituting the x with the additive inverse of x, and that is negative x. The first thing that we are going to do in our solution is to copy our original function. And this is our original function. F of x is equal to 1 over x raised to 7 plus 4. Then afterwards, we are going to replace x with negative x. And this is it. F of negative x is equal to 1 over quantity negative x quantity raised to 7 plus 4, and we are going to remove the symbols of grouping. So what we are going to do is to simplify quantity negative x quantity raised to 7. So negative x times negative x is equal to positive x squared. Positive x squared times negative x is equal to negative x raised to 3. Then negative x cubed times negative x is equal to positive x raised to 4. Then positive x raised to 4 times negative x is equal to negative x raised to 5. Then negative x raised to 5 times negative x is equal to positive x raised to 6. Then positive x raised to 6 times negative x is equal to negative x raised to 7 plus 4, because we have the constant term here in the denominator of our rational expression. In writing an expression, the standard form is that the preceding term is always positive. That is why we are going to rewrite this in its standard form. And that is our f of negative x is equal to 1 over 4 minus x raised to 7, and we use the commutative property of addition, in which if we are going to add numbers, we are going to interchange the order of the addends. The sum is not affected. That is why that is the thing that we did in this particular expression to make it 1 over 4 minus x raised to 7. We are going to check if this resulting expression is an additive inverse of 1 over x raised to 7 plus 4. What we need to do here is to get the negative of this rational expression, which is 1 over 4 minus x raised to 7. And this is it. negative quantity 1 over, because negative times negative is positive. And 1 times x raised to 7 is equal to x raised to 7 minus negative 1 times 4 is negative 4. That is why the negative of the rational expression 1 over 4 minus x raised to 7 is equal to 1 over x raised to 7 minus 4. Now, we have shown algebraically that f of negative x is not equal to negative f of x, because after getting the negative of f of negative x is equal to 1 over 4 minus x raised to 7, and the result is equal to 1 over x raised to 7 minus 4 is not equal to the original rational function, which is f of x is equal to 1 over x raised to 7 plus 4, and we can finally conclude that this rational function is neither an odd nor even function. And this can be validated using the graph of this rational function f of x is equal to 1 over x raised to 7 plus 4, and the graph was being obtained using the Mathway application from the cell phone. And this is the graph. This graph is not symmetric with respect to the y-axis and not also symmetric about the origin. That is why this rational function is proven not odd nor even function, and it is neither of the two. And now, let us proceed with the next slide of our exercise. Direction. Mentally solve whether its function is odd, even, or neither. In other words, we will not use algebraic solutions in identifying the function whether it is odd, even, or neither. Instead, we are going to use our techniques how to identify easily the function whether it is odd, even, or neither. And that is using our mental solution. Number 6. F of x is equal to 2x raised to 8 minus 5x raised to 3 plus 3. Take note, this is a polynomial function of degree 8 and it has 3 terms. What we need to do here is to observe the exponents of the 3 terms of the polynomial function. The first term is having an exponent of 8, the second term is having an exponent of 3, and this is a constant term in which the variable here is x with exponent 0. Therefore, the exponents are 8, 3, and 0, and these exponents are combination of odd and even. That is why, because of the second term, in which this is an odd exponent compared with the other 2 exponents which are even, and this makes this polynomial function f of x is equal to 2x raised to 8 minus 5x raised to 3 plus 3, neither an odd nor even function. Number 7. F of x is equal to 3x raised to 5 minus 7x cubed plus 4x squared. And this is a polynomial function of degree 5, and this is a quintic function. There are 3 terms in this particular function, and the exponents are 5, 3, and 2. And because of the third term, which is 4x squared, and the exponent is even compared with the other exponents which are odd, and this makes polynomial function number 7 f of x is equal to 3x raised to 5 minus 7x raised to 3 plus 4x squared, neither an odd nor even function. Number 8. F of x is equal to 3 over x raised to 4 plus 1, and this is a rational function in which our numerator is a constant term and our denominator is a quartic polynomial degree 4, and we do not have other term which has the variable x. because we have just only the quartic term and the constant term. And this is an even function. And if we are going to solve for f of negative x of this function, f of x is equal to 3 over x raised to 4 plus 1, that will be resulting to itself. And that makes this function even function. Number 9 is also a rational function. F of x is equal to x over x raised to 3 minus 2. And because of this constant term, this makes this function neither an odd nor even. Now, number 10. F of x is equal to 2 over x raised to 3 minus x raised to 5. And our numerator is a constant term. It means that we will just only scrutinize the exponents of the denominator. If all the exponents of the denominator are odd, and this is an odd function. And that will be applied if our rational function is containing a constant term only in the numerator. What we need to do is to scrutinize only the denominator. If the terms of the denominator are having the exponents odd, and that belongs to odd function. And if the terms of the denominator have all even exponents, and that belongs to even function. Number 11. F of x is equal to 5 over 2x raised to 4 minus 2x squared plus 5. And all of the exponents of the denominator are even. And this makes this function f of x is equal to 5 over 2x raised to 4 minus 2x squared plus 5, which is a rational function, even function. Number 12. This is also a rational function. F of x is equal to 3 over x raised to 6 minus 2x cubed plus 5. And since that our numerator is a constant term, we are going to proceed automatically with the inspection of the denominator. And because of the second term, in which the exponent is 3, and this is odd, compared with exponent 6 and 0, and these 6 and 0 are even, this makes this function neither an odd nor even. Let us proceed with number 13. Number 13 is a polynomial function of degree 9 with 3 terms. F of x is equal to 3x raised to 9 plus 2x cube plus 3. The exponents are 9, 3, and 0. And because the exponents are combination of odd and even, this makes this function f of x is equal to 3x raised to 9 plus 2x raised to 3 plus 3 neither an odd nor even. Number 14. F of x is equal to x raised to 7 minus 2x raised to 5 plus 3x cubed, an odd function, because all of the exponents of this polynomial function of degree 7 are odd. The exponents are 7, 5, and 3, and they are all odd. Therefore, this belongs to odd function. Number 15. F of x is equal to 3x over x raised to 5 minus 2x. And this problem number 15 is very similar with the previous problem number 4, in which our numerator is containing a variable x and the denominator is containing a polynomial with variable x. All the terms of the denominator contains a variable x. That is why what we need to do here is to mentally factor the common monomial variable x, and afterwards we are going to mentally cancel so that the numerator will be constant only, and we can apply the previous technique that we have. Then after factoring out the x, we can cancel x here. That is why what remains in the denominator is x raised to 4 minus 2, and 4 and 0, which is the exponent of the x in the constant term 2, are even. And this makes number 15, f of x is equal to 3x over x raised to 5 minus 2x, an even function. Number 16. And this is a rational function. F of x is equal to 2x over 3x raised to 4 minus x squared. And we can apply same technique that we have done in number 15, in which we are going to mentally factor out x both from the numerator and the denominator, and afterwards we are going to mentally cancel the x, and what remains in the denominator would be 3x raised to 3 minus x. And exponents 3 and 1 are all odd, and this is an odd function. Number 17. And this is also a rational function. F of x is equal to 1 over x raised to 2 minus 3. And this is even function because the exponents are 2 and 0. And 2 and 0 are even integers. Take note, if we have a constant term, understood that this constant term is beside variable x with exponent 0. X raised to 0 is equal to 1. That is why 1 times 3 is equal to 3. And times negative 1 is negative 3. Number 18. F of x is equal to 5 over x raised to 5 plus 3x cubed minus x. What we need to do here is to inspect the denominator because the denominator is containing 3 terms and each term contains the variable x. All the exponents of the variable are odd. They are 5, 3, and 1, and this is an odd function. Number 19. F of x is equal to 3 over x raised to 4 minus 2x cubed plus 3x. And this is neither an odd nor even because of the first term, which is having an exponent of 4, and 4 is even, and 3 and 1 are odd. Number 20, and this is the last number. F of x is equal to absolute value of x plus 5. Now, absolute value function has a graph which is a V shape, either opening upward or downward. And this absolute value function has the vertex. If the vertex is along the y-axis, we can say that our absolute value function is symmetric with respect to the y-axis. That is why number 20 is an even function. Why? Because this is an absolute value function with V-shaped graph in which it is opening upward and the vertex 0 and 5 is along the y-axis. Now, to validate if a certain function is odd or even, you are going to use the Mathway application. You are going to download Mathway application in the Play Store of your smartphones so that you can validate whether a certain function is odd or even, and that is simply scrutinizing the graph. If the graph is symmetric with the y-axis, that is even. If the graph is symmetric with the point of origin, that is an odd function. That ends our exercise regarding odd and even functions, and we will have our assignment in this particular lesson that will be uploaded in our Facebook group. Once again, good day to each and everyone.